So let's take a second to review what we did on Monday. Let me get to the right page. We factored completely given a factor, right? That's right, Miss McGee. Thank you. In other words, let's say I had f of x equals 2x cubed minus 11x squared plus 2x. Nope, let's do plus 3x plus 36. I'm sorry. And let's say that x minus 3 is a factor. Quiet without John hearing me. Tell me what we did if we were asked to factor this completely. What's the first step that you do? Divide. You divide by x minus 3, right? What goes on the outside when you divide by? This is the lesson from Monday, yeah. This is a review. All right. So what goes on the outside? Positive 3. Give me a listing of coefficients inside. I'm sorry. 2. Question. Everybody okay so far? All right. Drop the first. That's right. That's 6. Add it. That's right.
15.
How do I know I've done it right?
No remainder.
No remainder. If I divide by a factor, I get no remainder, right? David, you got this section, don't you? I'm proud of you. All right, so then we said after we divide, we rewrite it, right? Okay, so let's rewrite this. Oh, I'm sorry. If I rewrite this, I have x minus 3, and then I have what? That's exactly right. Exactly right. And then we take this and we factor. And so to factor, remember, we multiply a and c together. What's 2 times negative 12? Negative 24.
What do?
It's got to add to negative 5. Negative 8 and 3. Y'all are exactly right. Okay. Back to that factoring in chapter 1. Yes? All right, so I've got x minus 3, 2x squared, minus 8x plus 3x minus 12. Is anybody confused? What? Rewrite it? Yep. And then slash it? So, no, don't feel dumb. What do we take out of the first 2? 2x. What's left when we take out 2x? How about these next 2? 3. What's left? And now I can take the x minus 4 out, right? So I get right? So what we're going to talk about today is we're just going to add a little step on here. If I asked you to find the zeros, now the zeros are the places where the graph crosses the x-axis. If I asked you to find the zeros of the function, what would you do? You would put everything to 0. You would make it equal 0. And because I've got 3 things that multiply to give me 0, I would say, well then x minus 3 must be 0. Or x minus 4 must be 0. Or 2x plus 3 must be 0. Do we see why I've got these things multiplying together to give me 0, so one or more of them must be 0. All right, so if I solve each one individually, I'm out of room here, I'm sorry. I get x equals 3. I get x equals 4, and this is a two-step equation here, so I'm going to have to subtract 3 and divide by 2. So negative 3 over 2. I'm sorry, it's a scrunch down there at the bottom. So I get these 3 zeros. Now I want you to look at something for just a minute. I've got x equals 3. And let's just focus on these two that aren't fractions, and x equals 4. What is the relationship between the 0, and I don't mean the number 0, I mean the 0, the solution, the 0. What's the relationship between the 0 and the factor? What's the relationship between the 4 and here? It's just the opposite sign, right? So, what if I started this problem exactly the same way, but instead of giving you a factor, I said, here's a 0, find the others. Or maybe I use 3 to start with. Do you see that the process is the same? Because if 3 is a 0, that tells me that x minus 3 is a factor. Does that make sense? So that's all we're doing. Yeah. And x equals negative 3 over 2. Okay? Only now, instead of being given a factor, I'm going to be given a 0. But because I'm given a 0, I am given a factor. I just have to know how to write it. Okay? So let me show you what I'm talking about. This, by the way, is the factor and remainder theorems. Remainder theorem means when you divide by a factor, you get a 0 remainder, and then the factor theorem has to do with plugging in a 0. Okay, let's do, so this is the new stuff, which is also the old stuff. It's all one and the same. Let's say f of x equals x cubed minus x squared minus 22x plus 40. If x equals 4 is a 0. So what I want you to do is find all other zeros. Y'all ready? First thing I'm going to do is I'm going to divide by x minus and whatever that 0 is. So in other words, for this one, I'm dividing by what? X minus 4. Right? So on the outside of my synthetic division, what goes there? 4. Positive. You're exactly right. All right, so that's something that you can write to help you remember is when you divide by the same sign as the 0. It is exactly the same thing. The only thing that we're doing is instead of starting with the factor, we're starting with the 0, and then we're setting everybody to 0 at the end. But it's exactly the same thing we did Monday. Okay? All right, so let's set up inside. What goes in here? 1. Come on, pen. 1, negative 1. Drop it. multiply, add, multiply, add, multiply. How do I know I did it right? No remainder. Now, this does not mean that every time you synthetically divide, everybody always thinks when you synthetically divide, you always get a remainder of 0. When we get a remainder of 0, it's only because we've divided by a factor, which you will get in these problems. Y'all with me? All right, we're going to follow the same steps we did before. We're going to write it as a multiplication problem. So what do we get? X minus 4, because that's what I divided by, right? That's right. That is correct. Anybody confused? Don't go up too far. Y'all need me to give you a second to catch up with me? Y'all good? You good, Micah? You look kind of tired there. David. You're always tired, David. What'd you do yesterday? You were off school yesterday. So what you tired of? Let's finish factoring. David. Tell me what multiplies to negative 10 but adds to positive 3. 5 and negative 2. Right? So I have x minus 4, x squared. I'm going to do that negative first because it makes my life a little easier if I do. Ready to slash it? Hold up. Wait a minute. You did it the other way? That's fine. That's fine. I just always do the negative in front so I don't have to change that last sign when I do it, but it's either way. All right, when I take out an x, what's left? When I take out, what's the GCF here? What's left? All right, so now I can take the x minus 2 out. Yes? Is it factored completely? Meaning... Meaning, is there anything else I can factor? And the answer is no. So now I add one more step on here from what we did on Monday. And that is set each parenthesis equal to 0 and solve. That's the answer. So, and here's a little clue. Whatever your biggest exponent is, when I solve this, I got x minus 4 equals 0. So there's one answer. X minus 2 equals 0, so there's answer 2. And x plus 5 equals 0, so x equals negative 5 are your answers. Does that make sense?